Hello, today we are going to look at a case example from a three-person mixture and see how TrueAllele can separate out the major and minor contributors. There was a case that involved a shooting, and when the police arrived at the crime scene, they noticed the suspect drop a gun and a baseball hat. So this was the evidence that was collected, sent forward to the laboratory for processing, and the lab was able to have a high match statistic between the baseball hat and the suspect, but on the gun, they could only produce a very low CPI stat. So then we were sent the data from the gun. And here's an electrophoregram view of that data looking at one locus. We can see on the x-axis, this is the base pair size. On the y-axis is the RFU value, indicating the relative quantity of DNA present. And as you can see, there are 5 alleles here, which would indicate we're most likely dealing with at least a 3-person mixture. So if we want to interpret this data, we can apply a threshold method. And you could see, using a 200 RFU threshold, we've lost all quantitative peak height data, and we've now just created a allele list with these 5 alleles. We cannot separate out 3 people at all using this method. And what happens if you do the statistic at this specific locus, you're only getting a CPI stat of 2. So we need something more informative. We need something that's we need an interpretation method that's actually going to separate 3 people. So that's where the TrueAllele genotype method comes in. This uses probabilistic genotype modeling, and what it's going to do is at each locus, it's going to try out hundreds of possibilities and then apply these different models to the data and assess how well the fit is. So this is an example of the computer, one explanation it came up with. And what we're seeing here is in green. It's indicating that maybe the major contributor is a 13-15. And then the middle contributor might have an 8-11 allele pair. And then the minor could possibly be a 12-12. So what you can see is this is just one good explanation of the data, and essentially what's happening is you're getting 3 different people. You could separate them out using the quantitative data and using the genotype modeling. Now, as well as inferring genotypes, the computer is also looking at the mixture weight separation. So this is actually showing histograms for each of the contributors, and you can see on the x-axis is the mixture weight percentages, and this shows that your major contributor is about a 60%, the middle around a 30%, and the minor is about a 10% contributor to this overall mixture. But this picture is nice because it very clearly shows you have 3 separate and distinct distributions. Now here we're looking at the genotype separation between these 3 people. Again, we are just focused on one locus, and what you're seeing on the x-axis of each of these pictures is the possible allele pairs, and on the y-axis is the probability. So looking at the top picture, this is for the major contributor. You can see that almost all of the probability is assigned to the 13-15 allele pair. Now looking at the middle, most of the probability has been assigned to the 8-11 allele pair. And you can quickly notice that the genotype distributions between the major and the middle contributor are different. There's different allele pair listings, there's different probabilities assigned to each. So you could see there's there's already separation of the contributors. Now, looking at the minor contributor, you can see we do have some additional allele pair possibilities here. So, you know, the certainty level has decreased slightly, and it's giving probability to basically 3 possible allele pair values. And what you'll see is, although the minor is the most diffuse, it's still concentrated on some areas. At each locus, at each location, there are 100 possible allele pairs. And you can see for each of these contributors, it has been narrowed down. For the major middle, it's basically narrowed down to 1 allele pair possibility. And for the minor, you're now only looking at 3 strong allele pair possibilities. Now, what would happen, this is just hypothetically, if we were able to match a reference to each one of these contributors. Here you can see there's a different match strength assigned to each contributor. If we had someone who matched the major, that match score is going to be in the quadrillions. If we have someone who matches the middle contributor, that score will be in the trillions. And if someone matches the minor, that score will be in the millions. So you could see TrueAllele was able to look at this mixture, separate out 3 people, and assign different statistics. This would not be possible using the threshold method. What happens there is the same CPI statistic gets assigned to all the contributors, and you have no separation. So using TrueAllele, we were able to look at informative genotypes that provided matches and can provide matches at all 3 contributor levels. Thank you for watching.